So here we have a pump trainer unit with an electric motor, a horsepower monitor, magnetic coupling, centrifugal pump with an acrylic housing, and a water tank and some valves we can use to control flow through the pump. We also have a rotometer that we can use to monitor the flow rate of water through the pump. What we're going to illustrate here in this video is the relationship between the flow rate there and the horsepower. This is a machine. It is taking mechanical energy from the motor. It's using that mechanical energy in a way to motivate the flow of water. Being a centrifugal pump, the way it works, it flings the fluid molecules out from the center, so the fluid comes in through the suction. It's flung outward by the spinning impeller. That is adding velocity, which is kinetic energy, to the water molecules. As the water molecules strike the inside surface of the volute, they slow down, they lose some of the kinetic energy, but they gain potential energy. That's why we have a higher pressure on the discharge than we do on the suction. Now when we're doing this, we're imparting energy to the water molecules, and those water molecules then go up the pipe, through the flow meter, up and over into our reservoir, and get recycled all over again. So the energy that we're imparting to that fluid has to come from somewhere. Conservation of energy says there's no free lunch. You can't get energy added to fluid for free. It's got to come from somewhere. And in this case, the somewhere is the motor, and of course it gets its energy from the power grid. What we're going to do here is monitor the amount of horsepower of that motor, and we're going to compare that against the flow rate. What we should see is that the more water flow that pump is moving, the more kinetic energy it's imparting to the fluid, the more of a power draw, the more of a horsepower draw we're going to see over here on the electrical side. So here we go. Turning it on. So our quiescent power draw here is about 1 horsepower. Right now we have this valve almost all the way shut, just a little bit of flow going through just so we don't deadhead the pump. We have a slightly positive pressure on the suction. Basically it's the head pressure, the hydrostatic head from the water in the tank. So I'm going to slowly open up the discharge valve. That's going to let water flow go through the pump, and we're going to pan over here and see what happens to our horsepower. So here we go. I'm going to open up this valve. We should see a few things happen with the gauge too. Discharge pressure will drop, suction pressure will drop as well. Here we go. You can hear some of the turbulence of the water going through the valve. As I do that, notice our horsepower is up at 1.2. We also show some flow rate on the rotometer. I'll open up this valve some more. Rotometer goes up. Our discharge pressure has gone down. Suction pressure has gone down a bit as well. And now we're at 1.4 horsepower. Still more on the valve. Flowing even more water. Even lower pressure on the discharge. Even lower pressure on the suction. Not much more horsepower of the motor. That'll go up a little bit as I continue to open up the valve even more. So 1.4. 1.5. We're nearly at full flow here in our rotometer. You can hear a little bit of turbulence there, the gate and the gate valve. Notice our discharge pressure is just over 3 psi, so it's dropped quite a bit. Our suction pressure here, almost 9 inches of mercury, vacuum on the inlet side of the pump, the suction side of the pump, and we're drawing about 1.5 horsepower. Our rotometer is almost at the full mark here. We see a lot of turbulence inside the water tank, so we're really flushing a lot of water through there. So as I begin to close this valve off, that's going to restrict the amount of water flow going to the pump. That means less water going through, less mass that we're imparting kinetic energy to. And that's going to reduce the amount of power that the pump requires to spin. So I close this valve off, I have less flow. I'm going to start to see that horsepower reading go down. So 1.5, 1.4. I'm continuing to close off the valve. 1.3, 1.2, 1.1. I'm almost all the way shut. Our discharge pressure has returned to a fairly high value. Our suction here is slightly positive, no more vacuum. And I'm going to shut the pump off here. So, a quick demonstration of motor horsepower, discharge and suction pressures, and flow rate through a centrifugal pump.